All right. So I will be watching the chat box. So if you have questions along the way, feel free to toss those in the chat box. And if we have any callers in or other people, feel free to chat box or uh, speak up. So our signature assignment instructions are here. A psychologist is interested in a mindfulness questionnaire and whether it measures a single dimension or more than one dimension. The data from this study are recorded in the file that I have opened up already over here. The questionnaire has 15 items, so we can see over here 15 items on a Likert scale from 1 to 6, and the responses are coded S1Q1 to S1Q15, which we can see over here. When we scroll through this data, we can actually see that there are some missing values that are just marked by a dot. So that will come up once we get into our calculations, because if we look here, we have 95 participants, but we will only end up with 93 in our tables. So that's something to think about. So the first step says to carry out a principal component analysis with direct Oberlin rotation. So one thing to note is that a principal component analysis is a type of factor analysis. So when you're looking to find information about this in your books, you might find it under principal component analysis. You also might find it under factor analysis, as kind of, with factor analysis as kind of an overarching theme. So in my version of the Brace, Kemp, and Snelger book, I'm in the chapter that's entitled Factor Analysis and Reliability and Dimensionality of Scales. And I'm in section 2, which is entitled Performing a Basic Factor Analysis on SPSS. So if you have a different version of the book, it'll probably be on a different page, but hopefully the title is similar or the same. And if anyone happens to know the title of the chapter or the page number, feel free to throw it out for other people to benefit from. But if not, that's okay too. So the steps for all of this are, I think I'll just jump right into those because it's easier for me to go on and to explain some of the next parts once we already have SPSS. And thank you, Frank. So you're saying that this in your text is page 331. That's helpful. Thank you so much. So page 331. Does it have the same title, the Performing a Basic Factor Analysis on SPSS and Factor Analysis and Reliability and Dimensionality of Scales? Perfect. All right, cool. So, so just get started, I'm going to select Analyze, followed by Dimension Reduction, followed by Factor. And so depending on the kind of factor analysis you're doing, you might not need all of the variables, but because we're doing a principal component analysis and we don't actually know if there are any underlying constructs or if there's just one or if there are more, we need all of the questions to be able to analyze them. So all I did was I highlighted these all with Shift and then I moved them over. You could also move them over individually one by one if that's easier for you. In terms of selection variable, we don't need to include anything because that's not really relevant to what we're doing for this primary component analysis. So I'm going to go right down the line here with the keys. Hi, Lily. Thanks for joining us. Are you able to hear us and see the screen?
Yes, now I am. I'm sorry. Thank you.
Great. Yep, I see. All right, perfect. So Lily, to get you caught up, we are on page 331 in the 6th edition of the Brace textbook, or if you have the 5th edition, on page 364. And so far, all I've done was analyze dimension reduction and factor. And then once I did that, the variables that were over here, I moved over here. And I'm intentionally not selecting anything for here. So under descriptives, I want to check the univariate descriptives box, coefficients, significance levels, KMO and Bartlett's test of sphericity, and reproduced and anti-image. So if the 6th edition suggests any other ones, you're welcome to see what happens when you check them. But remember that because the assignments were written under the assumption of the 5th edition, the ones that you need will be these ones. So if you want to play with it after the fact, you're always welcome to play around with it. Under extraction, we want to make sure that this here says principal components, since that's what we're doing. We want it to be correlation matrix. We want to select scree plot. We didn't read all of the instructions here, but a little bit later it says consider the scree plot. So if we don't check this, we won't get that, and we need it. Under extract, we're looking at the eigenvalue greater than 1. We could set this level to whatever we wanted, but we're going to just leave it at the default for 1, since that tends to make the most sense. And we'll see a little bit later how it may have been valuable to change it, but we'll just leave it as it is for now. And then continue. Rotation. We know that we're doing direct Oberlin because that's what the assignment set up here with direct Oberlin rotation. So we need to make sure we have checked that. And we also need to, under options, actually, I think we're okay with options. I don't think we need to make any adjustments here. We could potentially suppress small coefficients if we wanted to, but at this point, I prefer to just have everything available so we can see what we come up with. So continue and okay. So this gives us all sorts of information. And if I look back at our instructions, so basically we've done question 1. We've carried out our principal component analysis with direct Oberlin rotation. So the evidence of this is going to be in your document by having a lot of these tables. We're not going to have all of them, but we're going to have a lot of them. So that's kind of your evidence of doing it. Plus, in words, you would say, data from 93 participants were considered using principal component analysis with direct Oberlin rotation and SPSS. So you're telling your reader what you did. So for number 2, this is probably the lengthiest process of the assignment, at least it was when I did it. So state as many of the indicators of factorability as you can. And it doesn't really give us any hints as to what that means or what that looks like. But when I did this, I was able to find 6 different indicators of factorability. A lot of them just came from reading the Brace textbook because they have a lot of them listed in there. So I'll go through each of them and show you where I found the information in the outputs that are over here. I don't necessarily believe that you need to have 6. You might have more, you might have fewer, but this just gives you an idea of the ones that I found. So if you found different ones and you want to include them, you're more than welcome to do that. The first one that and I mentioned before, actually at the beginning, looking at this descriptive statistics box, this is also evidence that you did this principal component analysis, but noting here that we have 93, and we originally saw 95 on our other document, wherever that is here. So just a reminder about that. And then one of the things that I made a point to mention in my paper, it's not required, it doesn't ask about it over here, but I thought it was interesting that Brace et al. Suggested at least 200 participants when conducting factor analysis or principal component analysis, and Warner suggested at least 100. So ultimately, we're not really meeting that expectation in terms of our N. So we're kind of, we get results here, but we're not necessarily sure how reliable they are because we ultimately don't have enough of a sample size. But anyway, we're doing what the assignment tells us to do. So if you want to mention that and be a super nerd like I was, feel free to do that. So as for those indicators of factorability, so question number 2. So the first one we can find in our correlation matrix. So Frank, good question. The N is going to be 93. So even though our original amount over here is a 95, because this one is missing a number and because this one is missing a number, the SPSS kind of omits those because, and there was a point earlier on when we did where we could have checked to replace missing ones with the mean. So if you might have selected that without going through the steps again. I don't remember on which screen it was, but there was a screen where we could fill in blank spots with the mean. And if we would have done that, then our analysis would show as 95. But since we didn't do that, or at least since I didn't do that, it's 93. So we have to go based on what SPSS actually ran. And since SPSS only used 93 because of those missing values, we would put 93. If you did it and did 95, that's fine because your table here would show 95 and your all this stuff that's here would show that you had input the mean in place of those missing values. So if that's what you did, then you're fine to put 95. All right. So in this correlation matrix, one of the indicators of factorability is that several of these values are greater than 0.3. So in the Brace textbook, they talk about how values that are less than 0.3 indicate that there's probably not an underlying structure. So when we're looking here, we see 0.4, 0.4, 0.3, 0.3, lots of different 0.4, 0.4, 0.5. So we see a lot of values that are greater than 0.3. So this is telling us that there seem to be some correlations going on. Because what this is ultimately doing is this is comparing, does question 1 seem to be correlated to question 2, to question 3, question 4, and so on and so forth. So when we see these high numbers, it's saying there seems to be some correlation going on here between these two questions, which could be indicative of an underlying construct. So that was my first indicator of factorability. And so I talked briefly about that information from the Brace book, and I included this table into my output. Now, I know that Dr. Flo has been really encouraging people to create tables on their own. If you are interested in doing that, by all means, this one is a hefty one. If you did it yourself, you would be more than welcome to just do the correlation portion of it without having to do the whole thing. Just make sure that you mention that this is extracted from this matrix and it's modified by omitting this for simplicity's sake. But if you just copy and paste it like into your paper, I mean, considering how many numbers are here, but obviously if this is your dissertation, you have to do it by hand. So never too early to practice, I guess. So the next two indicators of factorability came from this tiny box here, the KMO and Bartlett's test. So the first one is this Kaiser-Meyer-Olkin measure of sampling adequacy. So this 0.845 is important because basically the closer to 1, the better the indicator of factorability in the situation. So if it's 0.5, it would be okay. If it were 0.6, it would be acceptable. 0.845, it's pretty darn good. So that's a good indicator for us. And then this bottom part, hi Christian, thanks for joining us. And then this bottom part, the Bartlett's test of sphericity, is a significant value here with 0.000. So what that means is the test of sphericity assumption has been met because of that significant value. So Christian, if you're just getting caught up with us here, we have already done the SPSS steps for the first part, kind of for this number 1, and we're currently walking through number 2 and talking through the different factorability tests. I'm not really looking in the textbook right now, but we were, if you have the 6th edition of the textbook, we were on, well, starting from page 331, we're probably several pages past that. And if you have the 5th edition, I'm on page like 364-ish. So, all right. So anyway, talking about this KMO and Bartlett's test, that takes me through my 2nd and 3rd indicator of factorability. So then another one that I basically just wrote in the text kind of just how I talked about that. And then I also included this table. So this is one that's nice and simple. You could easily format it on your own in APA, just suggesting. And then the next one comes from our principal component anti-image matrices. So I wonder if I can, make this a little bit easier to read over here. There we go. So from this table, we see that none of the KMO measures on the diagonal are less than 0.5. Oop, and I need to be down here in the correlation part. So anti-image correlation, all of these ones that have a little a next to it are greater than 0.5. So we have 0.8, 0.7, 0.7, 0.8, and on down the line. So that is yet another indicator of factorability. And then, let's see. And then the other thing is in the principal component analysis variance explained by factors table, we can see the actual percentage of variance that is explained by the underlying factors. So that's under the communalities table. I think here we are. So what this is telling us is that 33% for this first question, 33% of the variance can be explained by the underlying factor of this questionnaire, or in this case, 30.7 or 60.5, 52.5, so on and so forth. So one thing to know is that, any of the ones that are less than 50% are actually pretty low. So these first two are pretty low and could be considered for omission. This one is pretty low and could be considered for omission, so is this one. When I did it, I left them all in. The assignment didn't ask us to omit any, so I didn't. But in reading the textbook, it talks about how if you're doing this statistical test for yourself, you might, just to make your results better. But I left them all in just to see what happened. When I did this table, I actually relabeled this extraction and I called it percent variance, and I actually changed it to 33.0, 30.7. You don't have to do that, but for me, it helped me better understand what those numbers actually meant. So it's up to you how you report that, but that's yet another example of how we know that this information is factorable. Then the final one that I included comes from, let me find the right table so I know what it's called. This is the principal component analysis, reproduced correlations, residuals. So I'm looking down here at the residual part. So another indicator of factorability is the smaller the residuals, the more likely the analysis is a good explanation of the data. So when we look at this, we have negative numbers, we have things that are close to 0, 0.0, 0.0. None of these numbers are high at all. So all of these really low numbers, all of these really low residuals are telling us that this is a good explanation of the data. So that right there it concludes 6 different indicators of factorability. So when it says state as many as you can, you all can do at least 6. You could find more. If you don't have 6, I don't know what the specific cutoff is, but now you know at least 6 that you can include. Let's see. Any questions so far on those indicators of factorability before we move forward to the part about the eigenvalue? Okay, great. So for number 3, how many components have an eigenvalue greater than 1? So there are 2 different ways we can find the answer to this question. The first one is this total variance explained. So when we look at this table, earlier on when we were going through the different analyze dimension reduction factor steps, there was a place where we selected an eigenvalue of 1. So that means that anything that is less than 1 has been omitted from over here. So we see that these 3 that are greater than 1 made it over to this part of the table. So the answer, the short answer, there are 3. Another way we can find those are from this scree plot. So we see here that we have, here's our eigenvalue of 1. We kind of drew a line over here. This, my hand is not very straight, but basically this is like just under 1, and then these 3 are all over 1. So write a brief results section with a suitable table to report which items load on each component. Okay, so this next part is when things get a little bit more complicated. So what I'm going to do is, first of all, I'm going to bring over this picture from my textbook. So I don't know if your textbook has the exact same results reporting section that mine does, but I figured I would at least take a picture to show you what my book says so you know where I'm coming from on this. So basically, this is what our results would look like or sound like approximately, of course, putting in our own data from the SPSS output over here. And then the table that it's looking for, with a suitable table, this is a suitable table. So you'll notice that there's no such table in the SPSS results, and we don't have any way to make that table happen. So this one you have to make on your own. So the way that I reported my results here, I'll read my stuff and you can kind of follow along on here to see what it all says. But the data were analyzed by means of principal component analysis with direct Oberlin rotation. And before I complete this, I should mention that this is on page 376 of the 5th edition. I'm not sure what page it is for the 6th edition, but if you were following through the steps of SPSS, it's probably a couple pages after where we paused. So you might flip there and just see how it compares. Anyway, all right, the data were analyzed by means of principal component analysis with direct Oberlin rotation. The various indicators of factorability were good. So that was those 6 things that we just went through. And the residuals indicate that the solution was a good one. 3 components with an eigenvalue of greater than 1.0 were found, which is what we were just looking at on that scree plot in that other table. The scree plot also indicates 3 components. The components can be thought of as representing 3 constructs of mindfulness. Combined, the components explained 53.926% of variance. So this is coming from right here. So we can see that our first component accounts for 37.07. Our second component is 9.005 for a cumulative of 46.080. The third is 7.847 for a cumulative of 53.924. So basically, those 3 things account for 53.926% of the variance in our thing. And then the component loadings are shown in table 8. And mine was table 8, but yours might be a different number depending on how many tables you have. So my table looks kind of like this, but of course it's labeled a little bit differently because we're not looking at different kinds of flowers. I still have my component 1, component 2, and component 3, but then I have it loaded with the different names of the questions. So for example, S1Q1, S1Q5 would be on this side, and then the values that we find on the, let me find the table, on the component matrix, or sorry, the pattern matrix table. Here we go, the pattern matrix table. So it was a little bit confusing to me at first to know how to figure out which ones go in which column, honestly. But the way the textbook described it, it made sense to me, and I must have missed it when I did it when I was in the class, because today it made perfect sense earlier, and I was like, how did I struggle with this so much before? But basically, you look at each question, and then you see whichever is the highest. So for question 1, the first component is the highest. So I would put my S1Q1 over here in this category. Number 2, the first one is highest, so I would put that in component 1. For number 3, the first one is highest, so that goes over here. Number 4 is the second one, so I'm going to put that over here. So you're going to go through the whole table, and you're going to get all 15 of yours over here. The other thing, I see your question, Frank, and I'll get there in just a minute. The other thing is that your values should be in descending order. So to organize them, first of all, I just went in this 1, 2, 3, 4, 5 order. But then once I got them categorized, I put them in descending order. So for example, in my component 1, my highest value was S1Q9 with this 0.812. So I started with S1Q9 and then 0.812, and then S1Q14, 0.690. So Frank, I see that you said, do we include anything above 0.5 on our table, or what is the cutoff? So I didn't cut anything off. I put all of them in because, I mean, we can cut them off. If you do cut them off, you would just want to make sure that you indicated that you cut off anything that was below 0.5. But, and I know that the textbook talked a lot about removing variables that were too low, and kind of pruning the data. And I think if we are doing this in real life, we want to do that to get the best results possible. But I didn't do anything too fancy because I wanted to just make sure that I was addressing the questions in the assignment and, you know, getting maximum points without potentially accidentally screwing something up because I didn't know what I was doing. So there have been a couple points along the way where it's like, oh, we could reduce this, we could reduce that, but I personally included everything. And I did, let's see, I don't think I mentioned it at this point in my paper, but I know at some point in my paper I did talk about potentially reducing or eliminating some. So feel free to keep them all in, but then say, you know, some researchers would remove these because it would improve the results. If that, you know, if you feel like that best captures the learning that you took away from the assignment. So that gets us through the brief results section and a suitable table. And then from there, it says, consider the scree plot and how many components does that suggest? So we already kind of talked about that in our results section, where we said the components can, oops, here we go. 3 components of an eigenvalue of greater than 1.0 found. The scree plot also indicated 3 components. That's up to you though. I mean, some people would argue that we see 1 because there's this big, huge drop right here on the scree plot. Some people would argue 3 because these 3 are all greater than that 1 eigenvalue. So you can make the case either way, for 3 or for 1. It's up to you. But if you are, you know, so whatever you want to do for that scree plot thing. I didn't personally include an extra section for this question because I already addressed it here, and then later I address it with these other questions. But if you want to just make sure, you could have a separate section that just says scree plot to make sure that you get everything that you need to for your points. So any questions about scree plot, number 3, number 2, or number 1 before I move on? Okay, Frank, Christian, Lily, any questions? No? Okay. Christian, any questions from you? I'll take that as a no. Okay, great. Sounds good, Christian. Thank you. Yeah, Lily, I'm definitely recording this. And I also, like I did the last few weeks, I recorded like a micro version of this where I run through it a little bit more quickly. So whether you want the in-depth, you know, kind of deeply explained version like this, you're welcome to watch this. Otherwise, it's actually going to be in 2 videos because my screen recorder only does 15-minute chunks. And the first one got me as far as we are right now in 15 minutes, and then I have to do the rest. So I imagine that'll be a little bit faster, probably like 10. So your choice between 25 minutes or an hour, but either way, there are some options. Okay, so the next question takes us to the analysis and loading it onto a single component. So what we just did with that table, let me find where I put that. So this is loading onto 3 different components. We loaded these onto this, we loaded this onto this, we loaded this onto this. Now it's asking us to load all of them onto a single component, or see if we can. So how would you alter the analysis to assess which items load onto a single component? So the short answer to that is, just flipping through my pages here, to get where I need to go. Actually, I think I went past where I want to go. Here we are. Yeah. So to answer that question, the simple answer is that we can force a single factor analysis. So we're going to ultimately go through our factor analysis steps just like we did before, but we're going to change some things, which some of our tables are going to look exactly the same and some of them are going to look different. So the way I worded it was, to determine which items load on a single component, the same example data set with 93 participants were reanalyzed by forcing a single factor analysis. So let me walk through those steps. So we've got analyze, dimension reduction, factor. So far everything's the same. We already have all 15 of these moved over to here. We're going to still leave selection variable blank. Under descriptives, we're going to leave these all checked like we did before. Under extraction, let's see here. So this is what I was talking about before when we could have changed our eigenvalue to be higher so that it would omit things that were, maybe less than 3 or less than 2 or whatever. But for now, what we're actually going to do is select fixed number of factors. And we're only going to restrict one factor because basically we're forcing this to be a single factor. So now we're finding out, do all 15 of these load onto this one factor, or are there any that don't load onto it? So let's see, which variables would load with the 3 eigenvalues above 1, please? So the variables that loaded above 1, just a second here. Can I scroll over here? So these components right here are the ones that are above. Or you're trying to figure out specifically. So the question is how many components. It doesn't tell us specifically which ones. So we don't necessarily know specifically. We just know that there are 3. They just have, right now there is like imagining 15 different components, and then this is just saying that these 3 are all over that 1. So these are components. So ultimately what we're doing is we have this questionnaire. So sometimes questionnaires are trying to find out one thing, but sometimes a questionnaire is trying to find out different things about you. So let's say, like, if you've ever done like a Myers-Briggs test or whatever, that is trying to figure out probably like either 4 or 8 different factors about you. So you do all of these different questions. Some of the questions are going to help you figure out if you're an E or an I. Some of them are going to help you figure out if you're an N or whatever the opposite of N is. I don't have them memorized. So not all of the questions are getting at the same thing. So then afterwards, when you analyze that, some of the questions load onto certain factors. So some of the questions in that personality test are going to load onto whether you're E or I, or whether you're J or T, or I don't know. I don't know the different things. But basically, that's what we're doing here. So this questionnaire is about mindfulness, and we're trying to figure out, should the questions be categorized into 3 different aspects of mindfulness, or are they all getting at the same underlying construct, which is just mindfulness itself? So I think when we look at this here, this is basically just telling us that there are only 3 components that have an eigenvalue greater than 1. But it doesn't tell us specifically, this doesn't tell us specifically which questions go on that, but that's where the table that we have to create does. So when I look at the pattern matrix, this question is getting at, let's say one of the aspects of mindfulness is, I don't even have a good example, is, ability to stay present. And then the other question is about ability to, guide your thinking. And then the other one is about your ability to relax your physical body or something like that. So what this is saying is the question 1 is about getting at your ability to stay present. So is question 2, so is question 3, but this one is about your ability to guide your thoughts. And this one is also about your ability to guide your thoughts. Oh, don't apologize. Yeah, I mean, this is all really abstract when we just look at these numbers and we don't actually think about it in real life. So I get it. It's really confusing if you just think about the numbers themselves. So yeah, that's what that is getting at there. Okay, so back over here. So we've got all of our variables over here. When it comes to extraction, we've now forced this one factor. So that's all good. Really, everything else should stay the same. We still have direct Oberlin. And then for options, so here, Frank, when you asked before about using 95 or 93, here's where if we checked this box here, replace with mean, our n would actually show up as 95 because those boxes that were empty would just be filled in with the mean. So if we excluded the cases listwise, we end up with an n of 93, but if we replace them with the mean, then we would have the 95. So it's up to you all how you want to do it. It doesn't specify over here how to do it, so you can pick either way, and as long as you explain what you did, you'll be fine. So I think we're good with that. Here's another place where we could suppress those small coefficients. So Frank, you also asked about that. So if we wanted to check that and, suppress things that are less than 0.1 or less than 0.5, it would just make some of our tables have less information, or maybe there might not be some aspects at all. So again, if you want to do that, you're welcome to. I just leave it because I wasn't sure I would be able to adequately explain what I did and why, so I just kept it simple. So click OK. So because we left out the ones that were missing, we still have an n of 93. So basically, I went through this next part in my paper pretty darn quickly. I went through all the same steps I did for the first part because we ultimately are repeating the same exact thing except for forcing that single factor analysis. So you can use that same reporting structure over here. You can use all the same tables that you did before. You can go back through and you can again talk about these indicators of factorability because they're all going to be pretty similar. So I have my principal component descriptive statistics table included. I mentioned again that we have fewer than 100 or fewer than 200 of a sample size, so that might not be very good for reliability. I talked about the indicators of factorability, including the correlation matrix that has a lot of values that are higher than 0.3, like this one and this one and that one. And I talked about how the KMO test is still 0.845, which is more than high enough, and the sphericity is still good, and the anti-image correlations are also still all above 0.5, like we need, and the percentage of variance explained is, I didn't necessarily say that it's good, but I at least showed it. So we can see here, though, that our correlation numbers have changed. This is not the same as before. So if we look at our S1Q1, this time only 19.3% can be accounted for, whereas the first time it was 33.0. So that's where kind of our first real big changes come in. So what we're seeing here, and I did include this table, but I again changed it to percentages of variance as opposed to the extraction number here. So 19.3%, 22%, 39.5, so on and so forth. So make sure that if you screenshot it or copy those tables before, you actually have to redo this one because it's not the same as the last time. And, you know, again, here's a place where we could drop low percentages. So we could, you know, get rid of anything that we think is too low. We could, you know, this 0.193 is pretty low, 0.22. I mean, basically a lot of these are low, well below 0.5. But I didn't remove any because I just didn't feel like I wanted to get into explaining and justifying why I did. So the last thing were those residuals. And remember, we want the residuals to be as close to zero or lower as possible. So lots of negatives, lots of zeros, close to zeros here. So that those are all good signs in terms of that factorability. So then we can look at our eigenvalues and our components. So this number is the same as last time. This one component is 0.5561. So this is actually the same as before. It still accounts for 37.075% of the variance. And if we look at the scree plot, this is going to look the same as before. But again, we have this big drop here. So it seems like there's this one component that a lot of things pertain to. And these other ones are really not all that strong. So yeah, according to the principal component analysis tool, variance explain loaded on a single component, and the scree plot, the single factor's eigenvalue was 5.561, which you can see there. And this component can be considered to represent 14 underlying constructs of mindfulness. I'll get to that in a minute. The component represented 37, right here, 0.075% of variance. So then I'm going to report my results, just like I did before, but it will be a little bit different this time because we ran the test differently. The data were analyzed by means of principal component analysis with direct Oberlin rotation with loading on a single component. So that's different because we loaded on a single component. Last time we didn't say that. The various indicators of factorability were good. So that's those 6 things that we just ran through. And the residuals indicate that the solution was a good one. One component was forced, which had an eigenvalue of 5.561. The scree plot also could be interpreted to see one single dominant component. The single component can be thought of as representing 14 constructs of mindfulness. Combined, the component explained 37.057% of variance. The component loadings are shown in table 16, which for you, your table number might be different. So again, here's what it looked like when we loaded 3. But when we look at we have to find our pattern matrix. So wherever that is. Pattern matrix, structure matrix. I wonder if I did something wrong I'm not finding my pattern matrix. Any thoughts, anybody? I'm a little bit stuck here. I don't know why. I'm going to try to do the analysis one more time and see if I just missed something, but oops, I didn't want to do that. Hmm. Interesting. Okay. Well, that's something I'm going to have to figure out. Well, you know what? Wait a minute. Wait a minute. Wait a minute. Aha. Okay, I'm fine. I did because all right. So I realized what I did here. So because I had, because I have my thing on my table in descending order. When I looked at this one, I'm like, mine doesn't start with this number, and so that's where I got confused because I have it in descending order. So that makes sense. I was having a moment of panic there, as I'm sure you could probably tell. So anyway, we have our component matrix here, and because we only have the one value, or the one, we forced one factor, we don't have to worry about the other table, we only have the one component here. So basically, when I look at these numbers, the higher the number, the higher the strength towards that factor or towards that component. So when I look here, the highest one is actually that 14, which is at 0.787. So I have my table similar to the way that we have it. I don't know what that means. Similar to this here where we have the three components, except for I just have a single component and I have all of them listed under it. And again, you have to kind of create this table for yourself since none of them in SPSS are going to look quite like it. But I have my components listed in descending order. So I'd have S1Q1 0.787, followed by S1Q7, which is 0.766, so on and so forth. The reason in my report I said that we're representing 14 constructs of mindfulness is because S1Q5 is 0.392. That is such a low number that it was omitted. It's less than 0.4, so it's probably not a very good question. It probably doesn't really relate very well to the rest of the questions on the survey. So, oh yeah, Lily, no worries. You're all good. So, so that is kind of the final step in terms of reporting out on this second version of the factor analysis or the principal component analysis. So do that and report the results. So we've done that. We have a bunch of different tables to back that up. So then I have a brief note in mind that just mentions why question S1Q5 would be omitted. You know, you could leave it in, but then you really, that question doesn't really seem to be getting at what you're looking for. So that's kind of why how I explained why I omitted it. So in reporting, would it be prudent to state that the 787 is possibly the best? So I see what you're saying. Well, so basically, what we are finding, and it depends on where we draw the line for the cutoff, but basically, you know, if you say, yeah, I mean, arguably you're looking at mindfulness, and if the questions get to your one construct of mindfulness, so you know that one question seems to really get to the foundation of what mindfulness is. So you could say, okay, I want to set my cutoff at 0.5, and I'm going to omit any questions that didn't, you know, that weren't at 0.5. As a researcher in creating your questionnaire, you can do that if you find that some of the questions aren't going to get you the results that you're looking for. I didn't do anything too fancy just because I like to just really go by the book or go by the videos because I found safety and security in that. But if you want to talk a little bit more about the strength of the things, you're welcome to do that. I just put my table with my components in descending order and put a note under the bottom. Since variable S1Q5 was less than 0.4, it was omitted. And then therefore my argument was that 14 of the questions adequately were could be loaded onto that construct of mindfulness. You know, and it's hard because in the example over here, all of these are so strong. These numbers are all really high. So there isn't any of that like lower number question stuff. So the textbook doesn't really give that much of a explanation for some of that. Yeah. I mean, this is all like just kind of our practice run for if we want to do quantitative methods or if we want to do mixed methods. So yeah, that's a good point, Lily, about our practice run for our dissertation. So then the next question is, what other analysis or analyses might you conduct when considering the questionnaire? And then explain your reasoning. So the question is a little bit open-ended, but I found my best answers just in sticking to this chapter in Brace and the chapter 20 in Warner. So considering it says analysis or analyses, you could probably get away with just one, but you might put in a couple extras to be safe. I listed, let's see, 1, 2, 3 that I suggested. So I'll just mention those here in case you want to look them up and understand them a little bit more. So there are several different statistical analyses that could be used for any data set. It depends on what your question is and what you're trying to find out. But for this example, you could have done a basic factor analysis as opposed to the specific principal component analysis. And if we would have done that, let's see, the basic factor analysis, we would have been able to consider the covariance between variables as opposed to the variance as found in the principal component analysis. So really that just you can get that from reading the textbook or whatever. Also, you could do a reliability analysis. If you do a reliability analysis, let's see. So what you're doing then is you're just testing if this tool, if this questionnaire is even suitable for this particular situation. So you're not looking at which questions are suitable, but you're looking at it as is the test as a whole appropriate. You could also, and related to that, I just had a comment from the Brace book. So, sometimes we have, we find a questionnaire, we're trying to research, attitudes towards, I remember one of the earlier things we did for this class was cross-racial adoption. So there's an existing tool about cross-racial adoption, let's say. And so we're going to research that and we're going to use that tool. Well, we can use a reliability analysis to test if that tool is appropriate for the population that we're going to use it in. And Brace mentioned that even a tool that's been previously tested or validated often needs to be retested because there are differences in cultures, language evolution, and different assessment conditions. So that's just one way you can test to make sure that any questionnaire or scale that you're using is actually appropriate. The third one that I listed is a principal component analysis with PROMAX. So our assignment asked us to do direct Oberlin rotation, but PROMAX is just a different option under the rotation. So, oops, didn't want to do that. So when I was going through this stuff before under rotation, there was this option over here for PROMAX. So that is one of the options. And the textbook talks about that a little bit too. So if you use PROMAX, it gives the researcher the ability to assess the structure of items within a scale. So, I mean, those are just some examples. You can use those examples. You could use different examples, whatever works for your explanation. And the places that I found the best information about this was in section 3 of this chapter in Brace et al., because that's where it kind of goes into the alternative options outside of the normal options that we went through, and then also in the Warner chapter 20. So then I ended my document with the conclusion, like usual, and with my references, like usual. So this one is a little bit different because it doesn't have the rubric, but when I formatted my paper, just like normal, I've got my title page, my abstract, I have my introduction, and then my first section is principal component analysis with direct Oberlin rotation. and then I put my stuff. And then my next heading is indicators of factorability, and I put all my stuff. And then my next heading is eigenvalues greater than 1, and then all my stuff, and then results, and then all my stuff, just to make sure that I'm addressing all of these questions. So even if I repeat stuff, I do it just to make sure I'm getting everything. But how you format your thing is up to you, but those are the things that I did that made me be able to be successful. So just some thoughts for you. And then a reminder for those, there's at least 2 tables that you'll have to create from scratch when it comes to the reporting the results section, because the SPSS output doesn't provide these exactly how they're formatted here. Any questions on any of these steps, any of these things before we wrap up for the night? Oh, good. I'm glad, Frank. Thank you for the feedback. Lily, Christian, any questions? Thanks, Lily. I'm glad it was helpful. And the videos usually take me a couple of hours to get, first of all, converted into video format and then to get uploaded to YouTube, but I'll try to get them uploaded tonight, or if not tonight, tomorrow, so that you'll be able to have them going into the weekend. And actually, you know what though, I can give you the first 15 minutes right now, because that one I already did before this, but I have to do this, then I have to finish it up after this video. And then obviously this, hour-long one will be done whenever it's done. These ones take forever to convert into upload, but. Okay, well, if there aren't any other questions, I will wrap up this call. I am available by email, WhatsApp, text, whatever. So if anybody needs anything, don't hesitate to reach out. Good luck with this assignment. And since this is the last workshop, I don't know if I'll get to interact with you in real time for a while, but good luck with this class and whatever you have coming up next, and have a good break. Good night to you, Frank. Good night, Lily. And good night, Christian.